So for this video, we're going to talk about conservation of momentum, inelastic equations, and then go over example problem number 28. So for this video, for this concept, first we're going to talk about momentum, which can be denoted as P, and the equation for momentum is P equals mass times velocity. So that's our equation for momentum. Next, we're going to talk about the conservation of momentum. So that's just the idea that m1 v1 equals m2 v2. So all that is saying is that the initial momentum has to stay the same if the conditions are like unchanged. So for example, if we can use this two-block system, initially this is moving with velocity v naught, and this is m, and then let's say this box hits a box with 2m, and they move together. We can use this equation, so we have m v naught should equal m2. To get m2, we add the masses, so we do m plus 2m equals 3m, right? So we have 3m, and then this v, we can say v final, that we can figure out what v final is in relation to v naught based off the idea that momentum is going to be conserved. So doing this, we would obviously find that v final would just be 1/3 of v naught. Okay, now the idea of the momentum being conserved relates to our next topic, which is inelastic collisions. In general, inelastic collisions are when kinetic energy is lost and usually momentum remains conserved. I'll give a little depiction of so this is an example of an inelastic, of a perfectly inelastic collision. Here's another definition. So this particle 2 is at rest, particle 1 is moving towards it, and then after, it's going to look like this. Both particles will be moving together. Of course, let's say this is v naught. It's going to be v final moving at velocity final, which obviously won't be the same as v naught. So now let's go to the problem number 28. Blocks A, B, and C are aligned along a straight line of a horizontal frictionless surface. The masses of blocks are m, 2m, and 3m respectively. Block A is initially moving at a speed of b, and they hit each other. A hits B, they stick together. Then A and B hit C and they stick together. So all we have to do for this is use our idea of conservation of momentum. So it's a perfectly inelastic collision because they stick together. So M, just like up here, that's going to happen, but instead it's going to be a third block, 2m, and then 3m. And this one, the initial velocity is v, right? So our initial momentum is just m times v. So now that has to be equal, we can add all these up, m plus 2m, plus 3m equals 6m times blank. So that blank is going to be v over 6. And then we're able to look here. We used this equation, conservation of momentum. We look here and we find, v over 6 is answer choice B, and that's going to be our answer.